हेलो फ्रेंड्स। आज हम बात करेंगे साइन नंबर्स के बारे में। नाउ जैसे आपके रियल मैथमेटिक्स में होता है, वी कैन रिप्रेजेंट ए पॉजिटिव नंबर बाय ए प्लस साइन। ओके, जबकि आपके पास एक नेगेटिव नंबर आप डिनोट करते हो विथ माइनस साइन। ओके, लेकिन ड्यू टू द लिमिटेशंस ऑफ electronic circuits, the digital circuits can only understand a 0 or 1. Okay, so we have to display or represent negative numbers or positive numbers in a such a way that it can be understandable by your digital circuits. Okay, so now take an example. As in unsigned numbers, suppose this is a number here 0 1 0 0 1 with binary. This is equivalent to plus 9. Okay, and this MSB is the most significant bit of the number, and this always happens in case of unsigned numbers. Okay, so in case of unsigned number, this MSB has its own specific purpose and it has its weight here, because if we replace this 0 by 1, the value of the number, binary number, will change. Okay, that is, now it represents plus 25. Okay, so in case of signed numbers, we use an additional bit to represent the sign of a even number. For example, here 0 1 0 1 0, let us suppose this is the number, then it is actually plus 9, and if we use to represent this minus 9, then it is like this. Okay, so here this 0 and 1 is used to represent the sign of the number. Okay, so 0 represents a positive value and 1 represents a negative value. Okay, now in this way your signed numbers can be of three different types. First, signed magnitude. Okay, second, signed ones complement representation, and the third is signed twos complement representation. Okay, now take an example. When we are talking about positive number, then a positive number will always be or you can say that positive number can have only one representation. Okay, like plus 9 can be represented like 1001 0 0 1 0 0 1 0 0 0 0 1 0 0 1. In both all these cases, this 9 will remain same. However, these zeros have no significance here. Okay, whereas minus 9 can be represented in three different ways: either sign magnitude representation, okay, or it may be signed one's complement representation, or it may be signed two's complement representation. Now, in case of signed numbers, if we are talking about, let us suppose we are talking about a number with 9. Okay, 9 requires at least 4 bits to represent its magnitude. So we need to have an additional bit to be added at this position that is used to represent the number. Now we can also represent this 9 with different lengths like 4 bit, 8 bit, 16 bit, 32 bit, or whatever may be the size, but at least 4 bits are required to represent the magnitude. So in this way, in case of signed magnitude representation, okay, suppose the number is a 0 0 0 0 1 0 0, this, okay, and we want to represent this number in signed magnitude. So plus 9 can be represented like this: 0 0 0 0 1 0 0 1, whereas minus 9 is to be represented like, because this bit is to be used as a sign bit, so we have to change this bit by 0 to 1. So this magnitude, because we are talking about magnitude, the magnitude will remain same, and this, okay. Similarly, in another example, let us suppose if we want to represent 13 plus 13, then plus 13 is 0 0 0 0. This is your plus 13, and in case of minus 13, in case of signed magnitude representation, it will be represented like 1 0 0 0 1 1 0 1. See here, the sign magnitude representation has same magnitude in both the representations, okay. Here in this case also you can see the dot. Now if we are using signed ones complement representation, okay, then in that case in case of signed magnitude representation, the plus 9 again has the same representation. Again we are talking about the 8-bit number, let us suppose, okay. So this will be represented like this, whereas minus 9 is 1 1 1 1 0 1 1 0. Here you have to take care about that all higher bits except its magnitude should be 1 in case of negative numbers. Similarly, in case of plus 13 is 0 0 0 0 1 1 0 1, whereas minus 13 is to be represented as 1 1 1 1 0 0 1 0, okay. And see here, if we want to represent plus 7, then plus 7 is 0 0 0 0 0 1 1 1, whereas minus 7 is to be represented like this: 1 1 1 1 1 0 0, okay. Now in case of signed 2's complement representation, the plus line will again have same notation in case of 8-bit representation, whereas minus 9 is to be represented as its 2's complement. So this number in 2's complement is to be represented like 1 1 1 1 0 1 1 1. Okay, where this is 2's complement of this number. Okay, similarly, if we want to represent plus 7 here, then plus 7 0 0 0 0 0 1 1 1, whereas minus 7 is to be represented like this, that is 1 1 1 1 1 0 0, and this is again the 2's complement of this number. Okay, now this is about 8-bit representation. If we want to represent the same plus 7 and minus 7 in 4-bit, then in that case in 4-bit plus 7 has its notation as like this, whereas minus 7, okay, this will be 1 0 0 1, and where this is 2's complement of this number. Okay, take a review here. Okay, signed one's complement, sorry, signed magnitude, representation, signed one's complement representation, and signed two's complement representation. Okay, starting with uh, plus 1. Plus 1 is represented like this. Let us suppose we are talking about 4-bit numbers only. Okay, so plus 1 has its representation like this in this case, and as we know that it has similar representation in all the three like this. Whereas minus 1, if we want to represent minus 1, then this must be 1 and this is 1 because it is a magnitude here. And where in this one's complement representation, it must be 1 1 0. Okay, whereas in 2's complement representation, this must be 1 1 1 and 1. Similarly, plus 2 has its representation like 1 this 0 0 1 0 0 0 1 0, whereas minus 2 1 0 1 0, because this is now the sign bit, and here 1 1 0 1, and here it would be 1 1 1 and 0, because when we invert it's because 1's complement will be 1 1 0 1, and when we add this one here to get the 2's complement, then it will gives us 1 1, that is this one. Okay, thanks for watching this video.